Alright, let's use our log laws. I've got 4 examples for you. Alright, log of 5 base 10, what's log of 4 base 10? As I said in the previous video, I don't even need to write the base 10 in. If I leave it out, everyone knows that it's going to be base 10. But I'm going to leave it in just for the time being. This is log law number 1 in application. Log law number 1, if you had the log of 2 numbers times together, you can split the log over both the numbers and add them together. So this is log law number 1, we have to make it run backwards. So I have a log of something plus a log of something else, same base. So it's not exactly factorising, but if you think of it, you like factorising, I factorise the log base 10 out, leaving 5 multiplied by 4 inside the brackets. As the logs are added, logs are indices, so therefore the numbers themselves have to be multiplied together. So, log base 10 of 20. First, very simple example. So second example, I'm going to combine 2 log laws together into one here. So firstly, I see this multiplier at the front of both of these. So this is an example where we're doing power law of logarithms. So I can take that 3 at the top as an index. So log of 5 to the power of 3, base 2, take away log of 10 base 2 to the power of 2. So take the multipliers from the front, put them up as an index. From there, I now have log of a number, subtract log of a number. So instead of the multiplication 1, this is law number 2 where it's the division 1. So I can now do log base 2, and these 2 numbers divided together. So we have that. So you can give the answer as logs base 2 of 1.25, or you can give it as log base 2 of 5 on 4. Now, this particular one, looks confusing, looks complicated. It's one of these ones that you just need to be told what to look for, so that now you're aware of it, you can look for it yourself when you come to do your own problems. So when I look at this, I go, well, they're both base 8, log base 8. 49 is not a power of 8, 343 is not a power of 8, so I think I'm struck with a bit of a problem. But what I do notice is 49 is a power of 7, 7 squared. Perhaps 343 is also a power of 7. And in fact it is. If you got 49 in your calculator, times it by 7, you would get 343. So you should be looking at, okay, can I turn 49 into a power of 8? No, I can't. I have a problem. 49 is a power of 7. Is 343 a power of 7? That'll lead you somewhere. So let's just do this. So log base 8, I'm going to write 49 as 7 squared. And for the bottom one, I'm going to write 343 as 7 cubed. So far, just straight up index laws have been applied. I'm now going to apply the power law of logarithms to both of these. That 2 is going to come out the front as a multiplier. Oh, by the way, that's not as a decimal point, that dot there on the bottom there is a multiply sign. And so this 3 I'm going to bring out the front as a multiplier as well. From there, the questions become very, very easy. Remember, the log of a number, it just produces another number. It's a messy, horrible, ugly looking number, but it's just a number. So up here I've got 2 multiplied by whatever log of 7 base 8 comes to, and 3 multiplied by whatever log of 7 base 8 comes to. That number and that number are the same number, because everything's multiplied top and bottom, they can be cancelled out. My final answer is 2/3. That's an easy one. Alright, let's see where this one leads us. 2 log x base 10 plus 1. Once again, I'm just going to begin by taking this multiplier at the front and doing the power law of logarithms backwards and move it up there into its index line. So it's going to be log of x base 10, and that 2 goes up there as a power. Now, this 1, we're dealing with log laws, so somehow if I can convert this 1 back to a log somehow, well, I know I'm dealing with logs base 10. Do I know anything when I take logs base 10 to produce a result of 1? Yes, I do. I know if I do logs base 10 of 10, that gives me an answer of 1. So that gives me the one up there. And now look what I've got. The log in base 10 of some number plus the log in base 10 of another number. I can apply log law number 1 in reverse. I can, for want of a better word, factorize that logs base 10 out the front, leaving inside the x squared times the 10, that x squared times that 10. So there's my final answer. Logs base 10 of 10x squared. So there's the 4 type of questions you're going to come across. Give me a moment, I'll put up a couple of entry card questions for you, and then I'll come back and talk to you in a moment. Now, here are your 3 entry card questions for this particular video. 1 and 2, straight out of the video you've just watched. If you search back through them, you'll find exactly how to do them. Number 3, also, everything you need is in the video. You just need to include some of your index laws that you've known previously. So once again, your log law, this multiplier at the front, this 1/3 at the front. Remember, you can go up here using the power law of logarithms. Then you'll have 27 to the power of 1/3. That's something that you will remember from your index laws. Apply that, then apply your next obvious log law to the situation and see where you go. So remember, if you get all 3 of them out, you're going great guns. If you don't, just show me your attempt, show me what you've been able to do, and that provides us a starting point for our next lesson. So I'll see you in class, and we'll see how you've gone on these 3.